Hello and welcome everyone once again to this webinar on managing Docker images using the JFrog platform. So before we get started here, I wanted to just give a little bit about my journey to JFrog. I've worked at a number of different organizations and worn hats well beyond any titles you'll find listed, as I'm sure many of you can relate to. My experience ranges from small startups to large organizations and everything in between, including both the private and public sectors. Okay, you can find more detailed information about me on LinkedIn. Please feel free to look me up and connect. Now, let's cover a brief session agenda and try to capture some of the key concepts we'd like to take away from today's webinar, and then we'll dive into some of this content. So we'll start off with a high-level overview of the JFrog platform deployment, which includes Artifactory, X-Ray, pipelines, mission control, distribution and edge nodes, and access federation. Next, we'll dive deeper into the relationship between pipelines, Artifactory, and Docker. We'll take a look at a real-life example of a simple pipeline which builds, pushes, and promotes a Docker image. Then we'll explore how we can better manage the SDLC using metadata, a core concept in Artifactory, which enables enhanced automation capabilities. And then last but not least, we'll discuss how we can adopt security tools and best practices to better protect us from modern-day threats which affect our software supply chains. We'll try to have a short Q&A at the end, but please feel free to post your questions in the chat as you may have heard instructed before. Excellent. So let's get started here with a high-level overview of the JFrog platform. Okay, so at the heart of the JFrog platform is our binary repository manager, Artifactory. Those of you familiar with the NPM leftpad incident understand the importance of not relying on public registries to host your production build pipelines. In addition to the security provided by features like include and exclude patterns in remote repositories, we can also use X-Ray to scan and secure all of our binaries stored in Artifactory. X-Ray can perform recursive and continuous analysis on our third-party open source software dependencies and take automatic actions to protect and bring visibility into vulnerabilities and license compliance. X-Ray can also be used at many different points throughout the SDLC, including at the point of distribution. Once your binaries are production ready, we can create a signed immutable release bundle and securely distribute that to a lightweight read-only Artifactory instance, which is running physically close to whatever system it is updating. This entire journey from code to production-ready binary can be managed using JFrog pipelines, which uses a YAML-based syntax to execute tasks in a declarative manner. This means that we can separate what to do from how to do it. This allows us to create and maintain complex pipelines of pipelines and use native tasks such as Docker push, which we'll take a closer look at during the live demo. Next, we have Access Federation. Access Federation syncs our security model across all of our JPDs, including for disaster recovery use cases, as well as syncing our security model to our edge nodes. And finally, we have Mission Control and Insights. Mission Control allows us to view our service topology and monitor the flow of replication and access federation, as well as show service health, where I can go into the topology of my JFrog platform deployment and see the service status, see if there's partial degradation of any of my services through this tool. And Insights allows us to view trends on metrics, such as code coverage with X-Ray, repository coverage, storage trends, distribution trends, and others. Okay, so that was a high-level overview of the entire JFrog platform. Okay, now we're going to do a deeper dive into where the JFrog platform fits into the overall SDLC, and more specifically, we'll dive into how it fits into our containers lifecycle, right, as a part of this application building process. So our SDLC starts with our dev team. we have our dev team, and they're declaring some dependencies in order to build their software project. When they declare these new dependencies, they need to resolve these dependencies from Artifactory. The first time that they try to resolve these dependencies, Artifactory will reach out to the public registry in order to resolve the dependency and cache it locally. For subsequent requests now, you have your Artifactory instance locally caching all of your dependencies that are required in order to build your project. Once you've gone through your local development and testing, you can go ahead and submit your code to your VCS. Upon commit of the changes, your version control system will take the VCS changes, and your CI server will go ahead and kick in and be able to build the project. As a part of the CI server's build here, it's going to need to resolve its dependencies through Artifactory. One of the benefits here is that as a part of the local development and testing that we did earlier, all of our remote dependencies, all of our third-party open source dependencies are all locally cached inside of Artifactory. So our build systems don't need to reach out to the public registry and go through the internet in order to resolve the dependencies. It can just reach out to the Artifactory instance. Once it's resolved its dependencies and built the final artifact, it can deploy these artifacts into Artifactory along with the build information and a bill of materials for that particular build. So now Artifactory can act as a system of record for all of your builds, dependencies, and everything that you're doing as a part of the SDLC. The next step here is to get our artifacts ready for production. And in order to do so, as part of the development process, we need to deploy and test our code. So once we've gotten our artifacts into Artifactory, we can additionally incorporate them into our QA and QC processes by contributing metadata based on deployment and tests that we're running. Once we've appropriately tested our artifacts, we can contribute metadata in the form of something like key value pairs, which will describe different attributes of a particular artifact. So for example, we could say QA functional test, pass or fail. And that could be the trigger for whether or not we want to move forward with that artifact into rolling out for internal distribution or to deploy to our production systems using some provisioning tools. Okay. As a part of the internal distribution rollout, we can go ahead and use our distribution mechanism in order to create that signed release bundle and securely distribute that out to these lightweight Artifactory read-only edge nodes. We can further use platform webhooks at different points in this process in order to kick off workflows and trigger build systems and trigger provisioning systems. Let's switch to a short demo on the pipelines process, and we'll take a look at a simple project here where we will build a NPM and Maven backend web application that we will be building and pushing through the system and eventually putting into our production repository to get ready for deployment. Okay, so you should be able to see now my Artifactory instance here. All right, so we've gone into the pipeline section here. And under pipelines, we're able to see that, first of all, there's this UI element to this, which allows us to view our pipelines and visualize really complex workflows, right? What we have here is a very simple workflow, which involves building as you can see here, involves building a front-end application, building a back-end application, and publishing both of them and building this Docker application, publishing the Docker application to our dev Artifactory, and then finally promoting that Docker image from our dev repository to our production repository, and marking it ready for deployment to production. So let's take a look at the syntax that we're using in order to set up this sort of a pipeline. So one of the first things that we'll notice here is that this entire syntax is written in YAML, right? We do have the ability to do some scripting if you want with Bash, but the idea here is that we can use these native steps like Maven build or npm build or npm publish and tell pipelines what to do rather than how to do it, right? And this way what we're doing is we're describing state, we're giving tasks and using these native steps and saying Maven build and simply providing it with the input resources that are required in order to build this application, right? Once we've provided it with the appropriate sources, now we can have this built out, and we can even specify things like output resources or have this trigger different events. So this would be one task, which is the build backend. And you can see that this build backend is going to be the trigger here for this build Docker app task. And if we go down to the build Docker app task, we can see here some of the input resources, which of course include the GitHub repository that gets updated based on the build backend. And of course, the input steps like build backend and publish frontend, which will trigger this build Docker app step. Okay, so we can go through this this type of a syntax and build out this application where we can trigger each one of these tasks separately. So when we do an update to our front-end application, we don't necessarily need to build everything out this way, right? And this is one of the benefits of us using Docker in the first place, is that we can modularize a lot of these different pieces of our application and be able to run these things independently of each other, right? So in this case, we can go ahead and build out this front-end application, repackage it, rebuild this Docker application without having to rebuild this entire back-end application, and simply refer to the appropriate binaries that are required for this dependency. Right? Once we're able to build out this application, we can go ahead and take a look at these commands where we are publishing this Docker application to our dev repository, and then eventually promoting it into our production repository. And you can see that we're able to use the native commands once again in order to interact with Artifactory as well, where we can do things like publish build information and promote build, right? And then here's that the native commands that we're using in order to build and publish the Docker application here with the publish build info, and using things like force X-ray scan, right? So here we have this set to false, which is, by the way, the default for this. But we could have set this to true here, and that would have forced an X-ray scan as a part of this build process. And we can use this in order to fail the build depending on the results of that X-ray scan. Okay, so as we're going through this, as we're going through the logs on this, I want you to pay special attention here to when we're looking at the publish app step, right? We'll see that this is actually going to be publishing the artifacts into Docker Dev Local. So let's take a look at one of these runs here. And we'll go down into the publish app step here. So at this point, we've built a front end and a back end application, and we've built a Docker app out of that application. Now, these are pretty simple steps that we're calling here. At this point is where we start that interaction with Artifactory. We've gone through the build process, and now we want to push our built artifacts into Artifactory. So this is where we're doing that publish build information. We're publishing the build and deploying the artifacts here, as well as in the previous step when we're building this Docker application, we are also doing the Docker push here. So we have the Docker push here, and then the build step, the build push here, where we're pushing the build information right after that. Okay, and you can see that what we're pushing to here is going to be the Docker dev local, right? So we're initially building and pushing to Docker dev local, and then publishing that build information. Now we're ready to go ahead and deploy from our Docker dev local to our development environment, right? We can hook our application into those testing environments as well. Based on that testing that we're going to do in our development environment, we can go ahead and annotate the artifacts appropriately and have that trigger the next step. Right? As part of this pipeline itself, we could have it go through the process of going through that build information. At this point where we're submitting the build information, we could have done an X-ray scan and set that to true here. Based on this X-ray scan and testing that happens, now we're going to jump to promotion of this Docker image into our production repository. So if we take a look here at this promote build, we can see that we're going to be grabbing this build and promoting it to the Docker prod local repository. Okay. So once we've completed this last step here, we can even have this producing an output resource, which is the promoted build information. And this output resource here can act as an input resource to another pipeline and be the trigger for a different workflow. So this is going back into that pipelines of pipelines workflow that I was mentioning earlier, right? We're able to build these really complex workflows because we can simply define things like input and output resources and chain things together and visualize our workflows that way. Okay. One of the major benefits that pipelines allows us is to maintain control while not losing flexibility, right? And it gives us features like extensions. So we can do things like define our own native Docker push or build commands, right? So the same way as pipelines has Docker push, which is a native command in pipelines and understands what is required in order to do a Docker push, you can define your own Docker push step, right? And you would have that as company name dash Docker push would be the type of step. And using extensions, you can create an extension source. This would be written in Bash, and you can describe exactly what it is that you want that step to do. And now the developers in your organization can simply refer to that step, and rather than saying Docker push, they'll say your company Docker push, right? And they can use that now as a native command. In order to build out these very complex pipelines. So you get some control and some standardization across the organization, while also giving your developers the flexibility to make use of that standardization, but also customize on top of it. Okay. So a couple of questions here in the chat that I want to respond to. If we already have a pipeline process to build Docker images, can we use Artifactory as solely a private repository to push and to pull from? Yes, you definitely can. All of these examples that we're going through today, and I'm talking about pipelines here in the context of Docker and Artifactory, but Artifactory works with multiple CI/CD tools, right? It will be able to work with Jenkins, TeamCity, GitLab, whatever you're using there. You can interact with Artifactory and use it as a Docker registry in order to push and pull your containers. By the way, one of the important things to note with using Artifactory as your Docker registry is that we've made updates to our application code to be compliant with the OCI runtime, right? So for those of you that are worried about the Docker deprecation as a Kubernetes runtime there, you can still store your Kubernetes-ready images inside your Docker registry in Artifactory on the latest versions of Artifactory. Okay. And another question here in chat was, when using the free tier, all packages released by developers are private, correct? So yeah, when you're using the free tier or whatever product you are using with Artifactory, that is going to be your artifacts, right? We're not making those artifacts available publicly. This is still a private registry. Okay. Now, great questions. I want to make sure I'm addressing certain questions that are very relevant to Artifactory and this presentation in particular. I want to make it very clear that you can definitely use Artifactory as a standalone product. When I'm talking about the platform and I'm referring to a number of different features and aspects here, we're just talking about how can we leverage the native integrations that are already available on the JFrog platform. Okay, but like I mentioned before, it can be integrated with many different tools. Excuse me. All right, so we've gone through a sample pipeline here. We've taken a look at how we're building this Docker application, pushing it into a Artifactory repository, and then calling the promotion API and moving it from our dev repository to our production repository. And again, we're doing all of these things using native commands. That's why our configuration here is so simple, right? We're just being able to do things like Maven build, and this is really a nice feature to be able to just say promote build and not have to worry about the underlying calls and API requests and everything else that's happening in order to go ahead and do that promotion, right? And simply specifying the target repository and where the resources are that are going to be moving. Okay. Excellent. So let's talk about a couple of different patterns as part of this process. Now, one of the things that I had mentioned earlier was, or one of the things I had alluded to earlier was version pinning. This is one of the core concepts in thinking about Docker, right? Is the whole idea here is that we're trying to make our applications very easy to deploy, and change management should become a lot simpler. One of the problems that we have with versioning is the default is going to default to latest. If you don't specify versions on your projects, on your dependencies, when I'm doing this build front end, when I'm doing this build back end, these Maven builds, these NPM builds have tons and tons of open source dependencies, right? And all of these dependencies are moving targets, especially in the case of NPM. I'm looking at a very quick moving target. And I want to make sure that what I'm including in my builds, what I'm including in my production repositories are properly tested, right? If I'm using practices like tagging things as latest, what's going to happen is I'm going to run through this build process. And as a part of rebuilding certain parts of the application, I'm going to be testing one thing and deploying something different, right? I could potentially run into the case where I've tested something, I've deployed it into my dev environment, I've done a whole bunch of testing on it, and then before going to production, when I rebuilt that entire Docker application, it pulled the latest from one of my dependencies, right? And that effectively has changed your application. There's things that you've tested which could at this point have broken, right? And this is what gets back to version pinning. This is why version pinning is important. Rather than specifying latest, if in that same rather than specifying latest, if I had specified the actual version that I want to include as a dependency, then here in this build front end, this build back end, I can be confident that my application has not changed as a part of this development process, right? Furthermore, if you'll notice, when I'm using things like promote build, right? The key here is that I'm not rebuilding anything. I'm simply taking something that I had built. I built it one time. I had pushed it into my development repository. And then I'm taking that exact same build and I'm moving it from dev to production. And then for my production deployment can grab the artifact, can grab the Docker image from my Docker prod local. Right. And what it's going to be grabbing is the same exact image that I did all of my testing with in my development environment and in my staging environment. Okay, so version pinning here is a very core concept. It's a highly recommended pattern of Docker, and it's exactly the kind of thing that Artifactory can help us better manage. Okay. All right, so let's go ahead and switch gears back to the SDLC and talk a little bit about automation through the SDLC and how we can leverage metadata inside of all of our artifacts in order to automate our processes end to end. Okay, so we should be back to the presentation here. Let's talk about the age of binaries, right? So if we look at the DevOps landscape since 2001, in the last 20 years, we've seen an explosion of binaries, starting from Agile to CI/CD to DevOps to microservices, and finally to Docker and Kubernetes, right? The breakdown of monolithic services into microservices was one of the huge drivers of this explosion of binaries. Whereas before you had a single application which was built out of this gigantic code base, right? And we moved that architecture into many little applications built from very logical separated sets of code bases, right? But this kind of an architecture, this shift to a containerized architecture meant that now we're dealing with a much greater number of binaries. And that presented its own problems, right? And a lot of those problems are something that we're going to address using metadata. Okay, but one of the biggest problems is that now we're looking at a needle in the haystack situation. When you need to move that one artifact from your development instance to your production instances, how do you know when to do it and what that artifact is? And that's the answer. The metadata is the answer to that question, right? Metadata will give us context into every single artifact. We can tag our artifacts with key value pairs, such as QA functional test, pass or fail, right? We can even tag it with properties such as production ready, which of course denotes that, hey, this artifact is ready to be deployed into a production server, or this artifact is ready for a release bundle for some internal distribution, right? So we can use metadata in order to give us context and be able to find the needle in that haystack, right? Be able to differentiate our binaries from each other and see what is deployed where and trace the binaries to not only what their source was, but be able to see the visibility of the binary from its origin all the way to where it needs to be deployed to. Okay, and of course, this allows us to pick the right binaries for production by using the context of the metadata. And we can change the state of an existing binary, right? So when we're talking about changing state here, what we're talking about here is rather than thinking about moving that binary from one environment to another, what we can think about it is as existing in a particular state. And that state describes the environment, right? So this would be dev, staging, production. And we can think of this binary as being dev ready, staging ready, production ready, right? And we can change the state of this binary based on different things that we're doing, like testing and security analysis, right? And this is one of the concepts that we're going to discuss next here. Okay, so in changing that state, we're going to mark the binaries for some sort of future use, right? Delete, release, whatever it is, and this will help us determine what binaries need to be promoted when and how, right? In the case of Docker images, this is extremely important because these Docker images, we've made them really generic, right? Like we have containers. The whole idea here is that containers should be able to run anywhere, agnostic of the underlying infrastructure, and they have all the dependencies, everything that you require for that application packaged in one place. But as a result of that, now you are lacking that context in terms of where do you want to deploy this thing. So in Docker, we use tags, right? And then the tags are versions and that will help us determine what versions of what need to be included in this particular Docker image. And in Artifactory, we use a similar concept of tags in order to determine which Docker images should be in what state. And that allows us to leverage this promotion pipeline, right? And the idea here is that we have quality gates, and these quality gates are doing checks like testing, like integration testing, unit testing, smoke testing, and then we have things like X-ray analysis as a part of these gates, right? So we can have our CI server build our code, produce a single artifact, and simply move that artifact, move that Docker image from one repository to another, right? Move from our integration to system testing to staging, and finally roll out to production. And at each point, we can have things like webhooks, which will notify your provisioning systems of the binary being deployed into the repository, right? So this can automatically kick off workflows, which will deploy from the dev repository to the dev environment, okay, and allow you to kick off the testing. And then as soon as you do the promotion from the dev repository to the system testing or the staging repository, that will, again, kick off the workflow of testing and staging and analysis and staging, okay? And we can move forward through all these quality gates and automate all the way from making our code change through to production. And our ability to do this automation is heavily dependent on these quality gates and how comprehensive these quality gates are. Which brings us to a very, very important topic, right? And the topic here is the transformation that the industry has gone through in moving from DevOps to DevSecOps. So let's talk a little bit about DevSecOps and what that is. So of course, it's development, security, operations. And the idea here is that we can't have these as separate entities anymore. At a certain point, we realized that development operations can't be siloed. and we brought them together into DevOps, right? And soon after, we realized the same thing is true of security, and it's for simple reasons. And here is an excellent example of why we don't want to have siloed systems. So you can have a security gate, right? And you can claim that you're doing security and you're covered. You've handled the security concern that you have, right? But if you're not properly integrating the security into all of the other processes that you're doing, it's easy for people to bypass your security. So as we can see from this image, we have the security gate here, but everyone's just kind of driving around this, right, very easily. So we have to be careful about how we implement the security tools and best practices that we have available to us, right? And that's the integration between development, security, and operations, is that we want to do things like build integration. And as a part of the development process, as part of that building process, we want to go ahead and fail. We want to go ahead and fail builds when they contain vulnerabilities. Okay. And I see another question here in the chat. What is the point of using metadata to indicate release-ready status if you utilize Docker dev local, prod local, etc.? Excellent question. So there's a number of, that was actually just one example of the way that you could utilize the metadata. It's not necessary to utilize the metadata in that way. It depends on your specific implementation, the vertical that you're working in. For example, people that are creating things like firmware, they might want to annotate certain artifacts with things like OS architecture, right? If you're doing something like a web application, which you're rolling out for a SaaS application, if you're doing a web application for SaaS, you might want to do something like a blue-green deployment. So you could use metadata in order to annotate your artifacts for which ones are meant for what end development environment. Right, and that doesn't necessarily have to be consistent with your development environments, right? It doesn't have to be consistent with dev, staging, prod. That could just be things like you're deploying to different types of different types of architectures, different clients, different versions of a product to different customers. There's a number of different use cases for that. Excellent questions, guys. So please keep these questions coming. More than happy to answer them as we go along here. And I see another question about Terraform provider. We'll have to get back to you on that one. I'm not sure about that off the top of my head there. So getting back into the security here. So one of the core concepts here, like we're talking about, is why is that integration so important? And it's exactly this, right? It's easy for users to bypass security if we're not properly integrating that, right, into the rest of our processes. Some of the other concepts that we want to be aware of when we're dealing with DevSecOps, one of the pitfalls that people run into when implementing security is they'll do too much too fast, right? And a good example of doing too much too fast is generating so many alerts that your users are actually slowed down by your alerts, right? They rather than helping your system become more efficient and more secure, you're actually slowing down your development processes. Basically, these alerts are getting in the way, right? So here's a great example of alerts getting in the way. Give cyclist space, and it's blocking the bicycle lane. So that's not the kind of alert that you would like to have, right? We want to do alerts that are meaningful and that are providing our users with some meaningful information about what's going on and how they can fix their issues and security issues and problems that they're dealing with, while enabling them to do their development, right? While not blocking them with these alerts. Okay, and then this is another great example of having some security, but because of the holes in your security, someone can very easily bypass and get into your system, right? So this is talking about coverage. You can write really great code. You can have excellent practices when it comes to things like peer review, fixing bugs, doing even static code analysis, right? But if you're not doing something like software composition analysis and not covering the entirety of your code, and let's be honest, 70% of our code base is open source software. It's stuff that has been written by other people, not written by us or any of our proprietary systems, right? So as a result, most of our code is unknown to us, and if we're not covering ourselves properly, someone can easily use that code as an access point to get into our systems. Okay, and if this image doesn't really quite clarify the vulnerability that we have to deal with here, I think this one really speaks volumes, right? This is really showing us, we have no idea what is going on with the supply chain in a lot of cases, right? Recent incidents with things like the SolarWinds hack really opened up the industry's eyes with respect to how vulnerable the supply chain is, right? The software supply chain, and this is a great example because this is the idea, is that there's so many links in this chain. It's difficult to know each and every link, right? In fact, it's difficult to know even most of the links, which is why you need something more automated. You need a tool that is continuously scanning and making sure that we're not introducing vulnerabilities into these Docker images, right? And with these Docker images, right, we're packaging all of these dependencies into our code and shipping it out to our production systems, and in some cases to our customers' environments. And so we want to be very careful about what we're introducing into that code. Okay, so when we're thinking about DevSecOps, it's crucial, it's important that we think about things like build integration, that we think about at build time, when we're creating these artifacts, when our developers are resolving these packages and they're putting it through the build system, this is a great integration point. This is one of the key integration points which will ensure that the things that you're putting out into production have been scanned, that they've been checked for vulnerabilities, that they've been checked for license violations, and they've been checked against your policies, right? Policies that you're setting, and you can set the automatic actions on these policies, which will tell Artifactory to block these vulnerabilities, to block these licenses which don't fit in with your legal cycles. So the build integration with Artifactory, the way it works is that we have our CI. It's going to go ahead and upload that build into Artifactory. In Xray, we've notified Xray about our indexed resources in Artifactory. So when that build comes into Artifactory, Xray is made aware of that build because it's one of the indexed resources, right? That kicks off a build scan inside of Xray, and Xray will generate some alerts, hopefully the right alerts to the right people. And then you can go ahead and send a fail build job from Xray through Artifactory back to your CI/CD system, right? So in this case now, your CI/CD system is going to receive a response from Xray, letting it know that the build should fail because a vulnerability was discovered, which violates one or more of your policies, okay? Once you have that response back, you can have your CI server fail that build, and now you can kick things back off to the developer and have them remediate the issue before going through the build process and deploying to whatever environment, right? You can be very fine-grained about how you're setting up these policies and how you're setting up the enforcement of everything. You can make sure that things are enforced differently for different environments. For example, in my development environment, I want to make sure that my developers have a little bit more flexibility with respect to what they're able to do, right? I don't want to stop development because of low severity vulnerabilities that could be potentially remediated in later cycles, right? What I can do is set policies such that dev has more lenient policies with respect to things like alerting. Staging has slightly stricter policies with respect to things like build integration. And then production is where I'm going to have very strict policies in which I'm blocking the download, right? I'm not allowing developers to even deploy or resolve, sorry, I'm not allowing developers to resolve vulnerable artifacts from Artifactory, okay? And that goes true for your CI system as well. If you block the download of a vulnerable artifact in production and your CI system tries to request that artifact, it will be blocked from downloading that artifact, which will effectively fail the build. Right, so that's build integration there in a nutshell. We can go much deeper here onto build integration. I would highly encourage you to read a lot more about build integration. There's a lot of great resources that we have available on our different wiki pages. Okay, and then last but not least here is this concept of shifting left, right? We realize that, over time you have to go through this build and deployment cycle in order to get to the testing and analysis phase. So here, when you're doing the testing and the X-ray analysis, you discover that there's a vulnerability. At the point that you discover this vulnerability, you're forced to now kick the process back to the developer for remediation, right? So there's a much better ROI in remediating the issue right here at the developer level from the get-go, right? So what we have to that effect is an IDE integration with a number of different IDEs, but what you can do is integrate your IDE with X-ray, and as soon as you import a particular package, a particular vulnerability, it will notify you within the IDE of the vulnerability and of what the possible fixed version is for that vulnerability, right? So before you even commit to your VCS and go through this expensive and time-consuming build and deployment cycle, you can fix your issues and move straight through this pipeline into production, right? So you get a much better ROI in remediating those issues. Okay. Excellent. So this brings us back to the promotion pipeline, right? We discussed a number of different things that we're going to be able to do as a part of this promotion pipeline in order to achieve this kind of an automation where we're building a project and then we're deploying it through the different environments, right? These quality gates need to be very strong. And so the different tools that we were looking at just now with X-ray, that's exactly what this is going to help us with doing. We'll be able to dive deep into these packages and dig into them in order to see vulnerabilities. So let me present my screen here again, and we'll take a slightly deeper dive into viewing the X-ray results, right? So what I wanted to show you guys is X-ray in the context of Docker. Okay, so let's take a look at this Docker package here. So we have this Docker image, and we can see here that it's been scanned by X-ray, and some high-severity vulnerabilities were discovered in it. We can drill down into this version. First of all, when we're looking at Docker images inside of Artifactory, we can see all the different Docker layers, all the different commands that were used in order to build this Docker image, right? So we have complete visibility into this thing. And then we can drill into this image here and take a look at the X-ray data for it. Okay, we can see in the X-ray data, we can see all the different security issues that were found. We can see all the licenses that were discovered. And based on these security issues and licenses, these were all the violations that were generated. Okay, these were all the violations that were generated based on the policies and watches that I had defined. Okay. So now going through these security and license issues, we'll be able to see things like the impact analysis. So you'll see that in the case of Docker containers especially, we have this view where we're recursively going through these images, right? So we're able to break down every single layer. And even within each layer, all the dependencies that are there are checked for the transitive dependencies. And so even at the violation level here, we can see this this impact analysis, which shows us exactly what layer contains what vulnerability. And we're able to drill down into each one of these layers inside of a Docker image. Right, so here we can take a look at this layer here, and we can drill down even further down to the lowest level of dependencies that's available here, right? So this gets down to the Maven artifact here that is vulnerable, and you can go in, view that component, and we can drill back up and take a look at where else does this component appear, what other projects, what other images does this affect, right? And we can see all the different layers that are using this particular component. Okay. So this view of looking at your containers, being able to get that visibility into every single image and diving deep into these containers, seeing how it was built, seeing all the vulnerability information, all the license compliance and security information, and then being able to do things like generating reports and sharing that out with customers or sharing that with internally with your security teams, whatever those may be, right? So all of these things allow us to build this promotion pipeline and promote with confidence, right? We can promote with confidence once we have good practices for things like security and testing. Excellent, thank you. So that's everything that I wanted to cover today. It looks like we do have a few minutes left here at the end to respond to some questions. And it looks like we have a couple of questions in the chat here. So different Artifactory plans have different amounts of GB transfer per month included. In the case of a virtual repository, do proxied requests to public registries count towards the GB transfer per month limit? So in the case of virtual repositories, when you're talking about proxied requests to public registries, what that's doing is it's actually using the remote repository that's been configured inside of that virtual, right? So although it might look like it's that virtual that is proxying out to the public registry, what's actually going on is that it's using the remote repository. The virtual repository is just a logical grouping for yourself so that you can insulate your end users from the configuration management of having to change every time a dependency changes, right? Ultimately, under the covers, what's going on is that it's using remote repositories. And yes, that would count for the transfer. Right, because you're going to be reaching out to the public registry and grabbing that package. Okay. Next question here is, you mentioned earlier the ability to mark artifacts using metadata as ready to delete. Can this be done via the CLI? We have seen errors, for example, in trying to delete artifacts tagged as production. Yeah, so definitely you can do this during the CLI. I apologize for the noise behind me, folks. So you definitely can do this via the CLI. You can add these properties via the CLI. When you're trying to delete these artifacts tagged as production, in trying to delete, one of the things you have to make sure about is that the artifact is not referenced anywhere else, right? If you have an artifact that's referenced in multiple locations, even if you remove one reference to it and mark it for quote unquote deletion, it's not necessarily going to be deleted until all references to that artifact have been removed, right? At that point, when the garbage collection kicks in, it will remove the actual artifact from your file store. So most likely, if you're trying to delete an artifact which has been tagged as something and you're trying to delete everything with that tag, if it's not deleting, it's likely because it exists somewhere else. Excellent questions. Have I answered everyone's questions here? Are there any questions that have not been answered, or if anyone has any follow-ups, please feel free to submit them. Okay, and there was a question around using the free tier, which I believe we've answered. And Ernest, please reach out to your account manager regarding the question about Terraform. I believe there is we do have a number of Terraform providers. We can even point you to our GitHub page where we're maintaining our Terraform. I'm not sure that is configured for GCR, so that's something I'm not sure about off the top of my head. But if it exists, we should be able to find it in that directory. Okay, so it looks like we have one other question here. If you have time, could you elaborate on what it means for an artifact to be referenced elsewhere? Yes, definitely. So one of the core concepts in Artifactory is checksum-based storage, right? And the idea behind checksum-based storage is we do a lot of deduplication of your artifacts. You could have multiple builds that are referring to the same artifact, and in your file store, the artifact will only be saved one time, right? You'll have that artifact, one physical copy of that artifact. But in the database, in your database records, there will be multiple database records which reference that artifact as a part of particular builds, right? Because Team A and Team B might be working on two completely separate projects, and there's a logical separation between the projects. But because of the nature of some particular dependencies, like if you take the npm leftpad dependency, for example, the reason it broke the internet was because there were so many systems and projects that were dependent on it. It's a small component and it's used very widely, right? So you could potentially have multiple projects, builds, teams that are dependent on that same artifact. And because of that deduplication, you'll have multiple references even though there's just one physical copy. Okay, so hopefully that helped to answer the question there. And by the way, when we're talking about references, that also includes things like release bundles and replications, right? So if you've done any kind of a replication of your build from one location to another location, then it's possible that that there's some orphaned reference which is causing the garbage collection to not kick in. Excellent. So any other questions? Last questions here. It looks like I think we've answered all the questions. All right. Thank you all so much for joining this webinar, and it was a pleasure speaking to you all today.